Welcome! I've heard you have some trouble understanding a concept. Let me help you. Let's explain the Lineweaver-Burk plot. For some context, Lineweaver-Burk plot is an example of a graph made based on an equation named Michael-Menten, also known as the M&M equation, which is used for the identification of the value of Pmax on enzyme kinetics. But now, what is enzyme kinetics? Enzyme kinetics is the study of the rates of enzyme catalyzed reactions, focusing on how factors like substrate concentration and inhibitors affect reaction speed. Concept of enzyme kinetics, and to create a rate, the values of the substrate and the velocity will be compared. In an ideal situation, the velocity will increase as the substrate concentration increases, and it will stabilize at a flat region called plateau, which will form when all enzymes has been activated with the substrate so the velocity reaches its Vmax. In real life, this is not quite true. See, the plateau region is not perfectly horizontal as there are many external factors that can alter this continuous line. This makes it very hard to estimate an exact Vmax value, and therefore the Km value, which will reflect the affinity of the substrate. A new way of creating a graph for proper estimation of Bmax and Km values was made. It is the Lineweaver-Burk plot. To begin with the creation of this graph, we will use the Michael-Menten equation I mentioned in the beginning, where we equate the value of V initial to the value of Vmax over Km plus the substance concentration, meaning S. For purposes of the graph, we must inverse it. Once this is done, and as you can see, there are still some factors to cross out, so after some maintenance, we finally have our final equation. Now, if we look closely, we can compare it to the usual form of a linear equation, and we can see that the values are equivalent. But be careful, because these values on the new equation are reciprocates from the original given values. I understand this could be a quite difficult concept to visualize, so let's put it in a graph. The 1 over V initial value will be the y-axis. The 1 over S values will be our x-axis. This is because we're comparing the velocity with the concentration of substrate. We can then plot the slope, which will be Vmax over Km. The point where the slope crosses the x-axis is -1 over Km. And if you're questioning why is it negative, it's because it is located on the negative side quadrant of the x-axis. And last but not least, the point where y-axis is intercepted. It will be called the 1 over Vmax, which will be the reciprocal value of the maximum velocity. The Lineweaver-Burk plot has many advantages. For example, it allows for an easy visualization in a straight line. Imagine a song with many unorganized instruments playing at once. It will be very difficult to distinguish each sound. But if you separate the audio tracks, you can clearly hear each instrument and understand how it contributes to the melody. The Lineweaver-Burk plot does something similar. It separates and sorts the data so you can clearly see the key values. It will also let us directly determine the Bmax value. And if this was your face after I said that, let me explain you how. 1 over Vmax is a reciprocal of Bmax. If the 1 over Vmax value increases and it moves upward on the y-axis, the value of Bmax decreases. If on the contrary, it moves down on the y-axis, the value of Bmax increases. Another benefit is that it can also be useful for comparing enzyme inhibition. The plot can also carry some disadvantages. 1. Unequal weighting of data. The value of S is very small, but in the graph it seems very large. This could increase the error margins. 2. Another disadvantage could be extrapolation is required for intercepts. It could be less accurate than other type of graphs as EH plot. This because it could be crowded at the point in which it will be very difficult to distinguish the different locations of Vmax in the y-axis or the Km values in the x-axis. However, this problem is not as big at this time since computers are highly advanced and will allow for a proper vision of the values. That's all for today. I really hope it helped you better understand the Lineweaver-Burk plot. Thanks for watching, and until next time.